Welcome to Miss Nam's Math World. Today we are going to discuss how to find the coordinates of the four centers of triangles with given coordinates. So let's have a revision on the way to find the centers of the triangles first. Now, let's have a look on the type of the triangle. For example, we want to have a triangle. If you want to find the in-center of the triangle, then we try to draw the angle bisectors. That means if you have one angle bisector, then the in-center will lies on it. Okay, in-center lies on this line. Lies on the angle bisector. If we only get one line, okay? So for example, you got a triangle here, and then you got an angle bisector. So the in-center lies on this line. But then you can see from the notes, we got the in-center here. So what should we do? If we have only one line, okay, so one line, then the in-center lies on this line, right? So in-center or other type of center, okay, lies on the green line. We cannot find the coordinates at this moment. But if you add one more lines, if you get another line, for example, I use this one. Again, I find the angle bisectors. So two lines is enough to find the in-center directly because you got the points of intersection. So this one is the in-center. Okay? So this is the way to find first. Sometimes we only need to find where the in-center lies on. It may be lies on somewhere on the line with only one line. So for two lines, then we can find the coordinates. So we also do this similarly for the rest of them. Okay, so we got the circumcenter. So for circumcenter, we draw the angle bisector. So one angle bisector, two angle bisectors in total, or three angle bisectors, of course, is better. Then we can find the circumcenter. So circumcenter got something like this. Okay. Alright, then the third one, centroid. So centroid, it means medians. Okay, medians is more troublesome. We need to first find the midpoint and then join the midpoint to get the median. So this line is the median. And you get the medians joined together, get a centroid. So lastly, altitude. So altitude is used to find the ortho center. Again, we can draw two altitudes to find the ortho center. Okay, that means for this part, our target is to understand the use of drawing one line of a special lines in the triangle. Okay, one line, two lines, we can find the coordinates of the centers directly. Now, we are going to draw the lines required for some special kind of triangles. So, the first kind of the triangle is you get a triangle with either the horizontal line or the vertical line is given. So this is horizontal line, so this one is vertical line. So with these two lines, we can simplify a lot because we are going to find the coordinates of something, which is much easier. First, we are going to consider the ortho center. So for the ortho centers, so again, we consider one line and two lines, right? So for ortho center, we have to consider first with one line, it is That means the height of triangle. Okay, all four center we use the altitudes. That means height of triangle. This is much easier to remember. So if you got a horizontal line, then the altitude is vertical. Okay, so of course we can get more than one line. Okay, so first we consider one line, right? Just like the last page. So horizontal line in this way, if you got a vertical line before, so there's one line, right? So for the second line, so you can rotate your figure so that you can again use your ruler to draw another right angle. Okay, so if you consider another one, so one line here, so the center lies on the green line. Okay, so center lies on here, lies on it. If you have two lines, then you can make sure that this is the four center. Okay, the center. So you can also do it similarly. Okay, but then one of the key points is you will be able to figure out it lies on that one. Okay, another one which is very easy to mix up with, which is called the circumcenter. So for the circumcenter, that means we are using the angle bisectors. Here, angle bisectors. So it normally doesn't touch the vertex. You see, normally it doesn't touch the vertex. So that means step one, you have to find out the midpoint. Somewhere here for the midpoint, okay? And step two, if you got a horizontal line, then this one is vertical, right? So the circumcenter also lies on it. Lies on it again. And then also we have horizontal. So this time, right? Oh, this time it is just, for instance, it is on it, okay? It doesn't happen every time, but sometimes it happens. Alright, so we can also do this similarly for other types of triangle. Okay, and then another something special for the in-center. Is for the in-center in DSE, it is more often to ask you to find the in-center for right angle triangle. More often means usually, but it is not, of course it is not always to happen. Sometimes you are also asked to find the in-center of triangle like this. So it depends on the type of the triangle given from the question, right? So you got a circle, and then the most important point for in-center is to actually understand that this center is actually the circle, and then the three lines are actually the tangents. The sides of the triangles are the tangents. Right, so these are, okay, 1, 2, 3, they are all tangents. So for tangents, you can got a tangent perpendicular to radius and so on. Sometimes you will need this piece of information. And then sometimes you can use the angle bisector. So it depends on how the question asks you to do. So also have angle bisector, something like this. Okay. So similarly, center, radius, and then tangents. So tangent properties. See if you still remember. So tangent properties is something like this. Okay, so these are some important things for the revision. And then we are going to do some MC questions. Now, let's study the DSE MC question. So in this question, let O be the origin. If the coordinates of the points A and B are 0, 12, and 30, 12 respectively, then we are asked to find the coordinates of the circumcenter. So please take the notes. Step 1. Draw the triangle. So with O, A, and B, right? O, and then A, 0, 12. And then B, 30, 12. So when you sketch the figure, so please note that they are actually having a horizontal line here. So this is the key point, horizontal line. Now we got the triangle here with a right angle. Alright, but this time right angle is not the concern. Our concern is to having a vertical line, right? So vertical line. So for the vertical line, when we want to find the circumcenter, so we can save time by only drawing one line, right? So you see, actually we have both cases. If you consider the horizontal line, then you can draw the line like this. If you consider this vertical line, so we can also draw a horizontal line. So you can get the midpoint here to be 0, 6. Okay, so at this moment, we already know that the y coordinate is equal to 6. That's it. And then we get the answer 8. But if you are not feeling happy to do it like this, you can also find the x coordinate, right? But by using the midpoint again, 15 and then 12. Alright, and then borrow the x coordinate to find the center of the circumcenter. So this one is a circumcenter with x coordinate 15 and y coordinates to be 6. Next, we are working for 2015 question 42. So again, to start with, we draw the triangle OPQ from the information here. O, and then this time 0, 60, P, and Q, 96 and 48. So Q somewhere here, right? Or if you feel unhappy, you can make it to be a little bit lower. So Q, 96, 48. Join the lines. And then for oval center, so we got these two figures, right? And then OP is vertical line. That means we can draw the horizontal line here with the right angle. But this time it is only enough for us to find the y coordinate. That means we have to find the x coordinate. So that means the oval center lies on it. And then we maybe let the oval center be AB. And then now we have the, I mean somewhere here, don't know where this is, it's AB, and then B equals to 48. That means it becomes A48. So it is the unknown. So how to find the oval center? So that means we have to draw one more height of triangle. It is called altitude. Another one. Like this. So this is A48. How to continue? So we know that these two lines are perpendicular, right? That means we can multiply their slope to be -1. The two slopes. So the first one is slope of PQ. And then the other one is the slope of the maybe called line L, is okay? So this is called line L. As we know that PQ is perpendicular to line L. Multiply together, you get -1. And then slope of PQ, P, and then Q. And the slope of line L, you have A48 minus 0, 0, because the origin also lies on the other two. So this is A, right? A and 48. After that, find the value of A to get the answer. So lastly, let's study this question. So this is modified from DSD question, alright? So this time we did not use as the origin again, and then we have the coordinates of P, which is 24, 0, and then Q, 0, 7. So this time you are asked to find the in-center of OPQ. So for in-center, that means we use the notes again. So this time for the notes, we don't use this one, okay? Use this part, and then we use the tangent properties. That means we can draw a circle here. All right, and then this is a center. So why we need to use that? Because we have tangent perpendicular to radius, okay, tangent perpendicular to radius, and we also know that this is 90 degrees, right? So that means it is a rectangle. Not really, not just rectangle, right? Out and out, out and out, it is indeed a square. And then we can use the tangent properties. That means these two are equal, let it to be y. These two are again equal, let it to be z. Alright, then of course we need to find one more thing, because right now we got the right angle triangle. In our notes taking also this part, okay? OPQ. So this is 7, this is 24, and then use Pythagoras theorem. So 24 square plus 7 square, and then take the square root equals to 25. Okay, to save time, I just take a note like this. Alright. After that, then we can form 3 equations, right? OQ is 7. That means R plus Z equals to 7, equation 1. Second one, OP equals to 24. That means R plus Y equals to 24, equation 2. R plus Y equals to 24. R plus Z equals to 7. Lastly, PQ equals to 25. So Y plus Z equals to 25, equation 3. So in order to find the unknowns, then of course we want to cancel out some of them. So maybe 2 minus 3. So you have R minus Z equals to -1. So equation 4. Okay, so our target is to find the value of R. So that means we use equation 1 and equation 4 and add them together, right? So 1 plus 4. So 1 plus 4, R plus R equals to 2R. And then Z minus Z equals to 0. Equals to 7 minus 1, 6. R equals to 3. Okay, so that means in center, of the triangle is equals to R equals to 3, 3. So I hope that this lesson is useful to find the centers of triangles, especially in the question with a horizontal line or vertical lines of the 4 centers of triangle to solve the MC questions. That's the end of today's math lesson. See you next time.